Hi, Science 20 students, Mrs. Udith. So we are going to go through some concentration calculation type questions. As you can see on the screen, I kind of have everything you need for you here. So if you want to grab your data book and your calculator, you can certainly follow along as we go through these calculations together. So as I always suggest with any type of calculation question, you're going to want to write down everything in the question so that you know what's the variables I have, what am I trying to solve for, and what equation would be appropriate. So the first equation, I will tell you what formula we're going to use right off the bat because this is kind of showing you all the different formulas. We're going to be using this formula. So the percent V over V equals my volume of my solute divided by my volume of my solution times by 100%. Okay, so just to note when you're using this formula, volume, whatever the volume units are, they have to be the same. So if the solute's in milliliters, your solution has to be in milliliters. If your solute is in liters, your solution has to be in liters. So the units, to be honest, as long as they're the same for these two, that's fine. Typically, when we would use this type of formula is if we have one liquid being dissolved in another liquid. So let's try this first question. It says a hair product requires you to combine 20.0 milliliters of hydrogen peroxide with enough water to produce a solution with a total volume of 120.0 milliliters. And they want to know our percent volume over volume. Okay, so now I can label these. Since we are dissolving the hydrogen peroxide into the water, that means that this is my solute. They told us that this is the total volume of the solution. And now we can plug those numbers in and solve. So we have our solute, which is 20.0, divided by our solution, which is 120.0, times it by 100. Now, for my final answer, you want to make sure that your final answer is always in proper significant digits. So if we look back to the values we were given here in the question, 20.0 milliliters, again, you'll notice that that is 3 significant digits. The solution, which is 120.0, is 4 significant digits. So my answer should be to the least number of significant digits, which is 3. So I'm going to round that 16.6 repeating to 16.7%. So there's my final answer for that question. So again, make sure you do try some volume over volume percent questions yourself. Let's take a look at the next question. It says a mosquito repellent says that DEET makes up 45.0% of the total volume. Okay, so there they've given me actually what my percent volume over volume is. It says that I have a 75 milliliter sample of the repellent, so that's the total solution there. And I need to determine the volume of DEET, so I'm looking for my volume of solute because the DEET has been dissolved in the solution itself. So this one's going to be a little bit different. We're still going to use that same original formula. Okay, so in this question, we're trying to solve for V solute. Okay, again, we've been given our percent volume over volume and our V solution. So what we need to do, a couple different ways. You can either plug in these numbers and then rearrange the formula. I'm going to go through the rearrange process with you though. So this is what I want to solve for. This is what I need by itself. We'll get rid of this 100%. The opposite of multiplying is dividing. So if I divide the other side by 100, that will get rid of that. And the opposite of dividing by V solution would be multiplying by V solution. Okay, and I'll times by V solution. All right, so that cancels that out. I'm just going to rewrite this because it's a little bit messy. So my new formula is My V solute is equal to percent volume over volume divided by 100% and times by V solution. All right, so let's put in our numbers now. 45 divided by 100. Oops. And times that by 75. And let's punch that into our calculators. So your answer you would have gotten was 200 milliliters. Okay, now let's take a look at the significant digits that we were given in the question. This number has 2 sig digs. This one has 3. Again, we're going to go with the lesser of the two. Now, this number, there's 2 different things we can do with it. We can either put it into liters or we can put it into scientific notation. In a question like this, I think it makes more sense just to turn it into liters. So if we divide that by 1,000, we end up with 0.2. And remember, I want 2 significant digits, so I have to add that trailing 0 liters. So there is my final answer. Okay, so there's 2 examples of using that percent volume over volume formula. Again, remembering that sometimes you will have to rearrange the formula in order to get your solution. Let's work on the next one. So the next one is going to be using a new formula. This is the parts per million formula. So parts per million, or ppm, is equal to my mass of my solute divided by my mass of my solution times 10 to the power 6 ppm. Because parts per million means how many parts in a million parts. So hence the 10 to the power 6. Okay, so let's take a look at the next question that we've been given in which we need to use this formula. Again, just as in the previous one, my units here, I'm generally actually going to be looking for grams, so I want my mass in grams. Again, remember, it does actually show you on your formula sheet mass in grams. So let's try the next question. It says a 200-gram sample from a bottle of water contains 5.4 times 10 to the negative 3 grams of mercury. Calculate the concentration in the sample of mercury in parts per million. So I'm looking for my ppm. Okay, now they said that the sample of water was this many grams, so that means that's going to be my solution. Okay, my mass. And they've given me my mass of the mercury, which is my solute because it's been dissolved in the water. So luckily for this one, we don't need any rearranging of the formula. We can just use it directly as is. So we're going to have 5.4 times 10 to the negative 3 grams divided by 200 grams times that by 10 to the power 6. So you'll punch that all into your calculator. And for a final answer, you should get 27. Now, let's make sure that that's going to work with our significant digits that we've already been given. This one is 3 sig digs. This one is 2 sig digs. So we're going to stick with the 2. And my units are parts per million. All right. So that's how you use that parts per million formula. Again, you might be getting some questions down the road where you have to do a little bit of rearranging. Just keep in mind, nice and simple, go over that kind of process that we used before to rearrange your formula. Let's go on to the next formula. So this one looks like this, C equals N over V. So our concentration equals number of moles over our volume. So the concentration, you'll see the units in the data book below, is in moles per liter. Your N, which is your number of moles, is measured in moles. And remember, this said moles per liter, so that means for this one, my volume must be in liters. Okay, so it has to be in liters. This is actually one of the more typical types of concentrations. So this usually is used by, for example, if we were doing a chemistry lab, and I needed to figure out the concentration of a certain substance based on what I had put in it, I could use this formula, or vice versa. So maybe I know what concentration I want to make of a solution, but I need to figure out, how much do I need to add to the water? Again, this is a formula that I could use for that. So let's look at the next example. It says a sample of water taken from a nearby lake is found to have 0.0035 moles of salt in a 100 milliliter solution. Determine the concentration of the salt in the lake. All right, so again, I've been given a number of moles. I've been given a volume. Now you might have said, okay, let's plug the numbers into the formula. We're ready to go. But I want you to remember back to the units, volume has to be in liters. So to divide that by 1,000 to turn it into liters, 0.100 liters. I'm just putting that 0.100 just to remind you that this has 3 significant digits. All right, so now we're ready to put the calculation into our formula. So concentration, which is what we're trying to solve for, is equal to 0.0035 moles divided by 0.100 liters. So you plug that into your calculator, and you end up with 0.035. Oh, sorry, I'm just reading the other number. Oh, no, that's right, 0.035 moles per liter. Okay, so let's look back to the original question. Remember, the zeros that come before the first non-zero do not count as significant. So this one has 2 sig digs. This one has 3 sig digs. Again, we want it to 2. So you can leave it like that. If you prefer scientific notation, you could put it in that form as well. But since this is technically 2 significant digits, we're actually just going to leave it in that form because it's good to go. So again, so far these have been pretty straightforward questions in which you're just directly using the information you've been given, no extra steps needed. We're going to take a look at a question where we might just need to use another formula in conjunction with this formula. So let's take a read, and then we'll figure out what we need to use. The next question says, I have a 65.0 milliliter of a 0.759 mole per liter solution of sodium chloride. Oh, sorry guys, you know what? This is actually going to be a different calculation altogether. I forgot to put my extra little formula one in there. So this last example is going to be an example using our C1V1 equals C2V2, or in your formula book, it's written as CIVI equals CFVF. Okay, so depending on if you use the letters or the numbers. Okay, you could say your initial versus your final. So whatever you kind of prefer for that, you can do 1 and 2, or you can do I's and F's. So kind of your choice, whatever you like better. So let's take a look at our final example. So sorry, I was writing everything down there. So we have a 65.0 milliliters, okay? So that's my volume. And they gave me my concentration, which is 0.759. Now, these ones in this case are my initials, okay? Then it says calculate the final concentration of the solution if it is diluted to a final volume of 100.0 milliliters. So this lovely formula here that we have, this CIVI equals CFVF, this is our dilution formula. So let's say that we had a very strong acid, for example, in the lab, and we wanted to dilute it to make it a little bit less harmful. This is the formula that we would use. So again, we try and figure out like how much water do we need in this final one, or what's the concentration going to be if I add this amount to it. So again, this is our dilution of solutions formula. So let's try the formula using the information given. Now again, for these questions, especially these ones, you just have to read very carefully. So here, since it said calculate the final concentration, know that that's the F, and they told me my final volume, which means the other two numbers must be my initial ones. So again, you just need a little extra reading for these. Now, if I'm trying to solve for CF, again, I'll rearrange my formula. So that means the opposite of multiplying VF is to divide VF. So CF equals CIVI divided by VF. So let's plug those numbers in. So my CI is 0.759. Multiply that by my initial volume, which is 65.0. And divide it by my final volume, which is 100.0. Okay, and for an answer, I would get, now again, let's look at the significant digits before you take that answer out of your calculator. 3 sig digs, 3 sig digs, 4 sig digs. So we're going to go to 3. My final answer would be 0.493 moles per liter. All right. So there I gave you an example of each of the different type of calculations, ones that you might have to use in this section. Now also again, if we were in a lab, I might have you do some of these concentrations as a pre-lab type of activity, because again, this is what I would use if I was making solutions for you in the lab. So what I'd like to do is I'm going to just pick a couple questions from the textbook, and we're going to go through those together as well now. Okay, so we're going to go through some textbook questions. So I'm taking a look at the questions on page 46, and I'd like to try number 35 with you. So we're going to do number 35 together. All right, so it tells us that we have 30.0 grams of NaCl. So sodium chloride, it's added to water to make an 800 milliliter solution. So for part A, it says use the periodic table to determine the number of moles in 30.0 grams of NaCl. So this is the type of question I was talking about earlier. So again, they've given us my mass. They've given us the final volume of my solution. And then for part A, they've asked us to figure out the number of moles, because ultimately we're going to want to calculate the concentration. So if you're given a question like this, and they're asking you to solve for concentration, but you haven't yet been given the number of moles, remember that you can use the mass as well as the molar mass of our substance, of our solute, to figure out the number of moles. So you might remember this formula: number of moles equals mass over molar mass. Remember, mass is in grams, molar mass is in grams per mole. So you'll need your periodic table for this question. For part A, we're going to figure out the number of moles, and we're just going to use this formula directly. So our mass is 30.0 grams. We'll just do a little side calculation on the side here for our molar mass. We're going to use the molar mass of sodium and the molar mass of chlorine. There's only one of each. So 22.99 is your molar mass of sodium. 35.45 is your molar mass of chlorine. So add those two together and you get 58.44 grams per mole. All right, so divided by 58.44. So again, type that in your calculator, 30 divided by 58.44. All right, final answer. Again, I want it to, let's look at my significant digits, 3 here, 3 here. I'm not including those because I wasn't given that in the question, so I want my answer to 3 significant digits, so it should be 0.513. Now, since we need to use this number of moles later in the question, and this is a rounded answer, I'm going to ask you to keep that value in your calculator. So don't clear it from your calculator, keep it in there because we're going to use it here in a minute. All right, so now we need to figure out the concentration using our C equals N over V formula. Before I can plug those numbers in, remember the volume they gave us here is in milliliters, but concentration is in moles per liter. Let's change that, divide that by 1,000, so that's 0.800 liters. And again, we're keeping our unrounded answer in the calculator, so 0.513 moles divided by 0.800 liters. And this is where it's important that you didn't round that original answer. Again, my final answer to 3 sig digs, 0.642 moles per liter. All right. So again, please make sure you practice some more calculation type questions, but that will be all the ones I'll be going through with you today. Good luck on the first unit, that module A, and stay tuned for more instructional videos. Bye-bye.